In Aberdeen, South Dakota, on one of the coldest days in February 2002, Vic's Crane and Heavy Haul moved an 812-ton truss bridge into place over a 15-track rail yard. The 312-foot-long single-span truss bridge was 57 feet 6 inches wide, 40 feet tall, and 23 feet above grade. Roger Haberman, Vice President of Construction, Industrial Builders Incorporated.
Prior to the opening of the new 281 bypass, the city of Aberdeen only had one main thoroughfare through town. There's an average daily traffic of approximately 7,000 vehicles, with a good share of that being truck traffic. The main hurdle to get this bypass around town was to cross the 15 set of track owned by the BNSF. The solution for the bypass and the crossing of the track was a 312-foot-long single-span truss bridge. We threw around a lot of different ideas as far as how we were going to launch the bridge across the track. It was in January that we met with Vic's Crane Service on site, and we were comfortable after that meeting with them on site, with their management team and their engineer, that they could do the job.
The goal in developing a method for moving the Highway 281 truss was to create a simple solution to a complex problem. The plan had to incorporate equipment that was capable of supporting the 812-ton truss, yet mobile enough to be set up easily and quickly. The allowable shutdown period for the Burlington Northern Rail Yard was only 22 hours. Within that 22 hours, the 15 sets of rail tracks had to be protected. The truss had to be moved onto its abutments, and then all equipment had to be demobilized from the yard so rail traffic could resume. The shutdown was time critical because the main rail line supplies coal from Wyoming to a power plant in Big Stone, South Dakota. Taking these key factors into consideration, it was determined that the truss was to be assembled on the north embankment directly on center line. With the bridge built directly to the north of its final location, the movement had to be only in one direction, eliminating the need for any turning. After the truss was assembled, the bridge was jacked up from its assembly elevation, gantry track was placed directly under each cord, and the truss was lowered onto custom fabricated dolly carts. The key element in making this solution work was utilizing structural towers on two separate transporters within the rail yard. These transporters had to be capable of carrying 223 tons each and be short enough to fit in the small space between the abutment retaining wall and the northernmost rail track, which was a mere 42 feet at the west cord and 38 feet under the east cord. With dolly carts under each corner of the truss, the bridge was rolled to the south to a point where the leading edge was cantilevered over the abutment wall and could be handed off to the transporters within the Burlington Northern Yard. All preparations were complete and the bridge was ready to launch, but the weather forecast called for high winds, which delayed the bridge move for 5 days. When Burlington Northern cleared their rail yard at midnight, it was time to start the launch. The first step was to build roads across the rail track with rock chips and timber mats. The two separate roads were placed with the utmost care. Each was surveyed and leveled to ensure that the roads created enough protection for the tracks, yet established a manageable grade. The rail yard lost 5 feet in elevation between the north and south abutment, and it was critical that each road was built up to the same elevation so the bridge could travel across the yard perfectly level. In constructing the two roads, over 800 yards of rock chips and 120 laminated mats were placed. Due to limited space in front of the south abutment, the transporters were pulled across the yard, utilizing dead men H-piles. Separate cables were run from each transporter to the dead men and then to an equalizer link. The equalizer link was connected to a single winch line to ensure that each transporter traveled at the same rate of speed. The winch was reeved in a 3-part bridle, allowing the bridge travel to be slowed down to a rate of 3 feet per minute. The bridge began moving across the yard. At 3 feet per minute, the tires on the transports made 1 revolution every 2 minutes 40 seconds. Such a slow travel speed allowed personnel located at each transporter and dolly cart time to observe operations and foresee any potential problems before they occurred. Travel was slow, but the responsibilities for each person involved within the launch were great. All personnel were able to communicate via voice-activated radios to give everyone the ability to stop movement at any given time. There were 2 ironworkers located at each dolly cart, 2 operators at the winch, and 2 trailer technicians at each transporter. 1 trailer technician was responsible for steering. A string line guide was placed next to each transporter to ensure that travel was straight. The second trailer technician had the responsibility of raising and lowering the transporter to ensure that the bridge was level. The South Dakota DOT had dictated that the bridge could not be out of level more than 2 inches during its travel across the yard, due to concerns of overstressing one individual cord. Many ideas and techniques were discussed to monitor the bridge during the move, but the simplest solution was chosen. A water tube level, with ends attached to each tower, indicated very simply to the technicians the elevation difference between the 2 cords. With all the key people performing their jobs flawlessly, the bridge traveled across the yard without a problem. Just a mere 90 minutes after the transporter started rolling, the bridge was lowered onto the south abutment. With the south end of the bridge secure, the transporters were pulled back to the north and used to raise the bridge so the dolly carts could be removed. As the north end of the truss was being lowered onto its bearings, the timber mats were being picked up and the rock chips were removed from the tracks. Although there was a 22-hour window to complete the project, it was completed in just 16 hours. By 4 p.m., the railroad was pulling their first train under the new Highway 281 truss bridge. In completing this project, VIX incurred 230 hours of engineering, 192 hours of planning and coordination, 1,271 hours on site, 0 accidents, 0 incidents, 0 injuries. Phil Dwight, area engineer for the South Dakota Department of Transportation, summed up the project this way. Construction of the overhead truss bridge in Aberdeen was unprecedented in South Dakota. Throughout the design and construction, the biggest concern was how the assembled structure would be moved into place. VIX Crane and Heavy Haul developed a perfectly executed plan that not only satisfied the time constraints, but presented the least amount of risk.